In today's lesson 9.7, we're going to take a look at using trigonometric identities. And what is a trigonometric identity? Right here, I have it down. It says it's a trig equation that is true for all values of the variable for which both sides of the equation are defined. So bottom line, there are a bunch of equations that you need to memorize, okay? They show what happens to be equal to each other. Like the first set of fundamental trig identities that we have are reciprocal identities. And now, if you recall earlier on in the chapter, we talked about how, like sine and cosecant, they're inverses of each other, and how you could take the reciprocal of one trig function and it'll equal the other. So, for cosecant theta, that's equal to 1 over sine theta. And you can see right here, secant theta is equal to 1 over cosine theta, and cotangent theta is equal to 1 over tangent theta. So once again, make sure, like all of these right here, memorize them. Make sure you have them down in your notes, and you're going to probably need to refer to them over and over until you actually do memorize a lot of these trig identities. If you don't memorize them, it's going to be very challenging, and it's just easier to memorize them straight from the get-go if you can. The more you practice them, I'm sure you'll memorize them as we go along. We have some tangent and cotangent identities right here. We have tangent is equal to the same thing as sine theta over cosine theta, and cotangent theta is equal to cosine theta over sine theta, which happens to be the inverses of each other. So we took the reciprocal, right? Pretty straightforward. We have some Pythagorean identities here. There are 3 of them. Now, with all 3 of these, if you needed to, you might have to take and solve for a particular trig function. So, for example, let's say with this sine theta, sine squared theta, hey, I can rewrite this equation. Let's say I know what sine squared is, or maybe the equation has something like 1 minus cosine theta. Well, you could figure out what 1 minus cosine theta equals. Because if I went ahead right here and I subtracted cosine theta to both sides, that equals, or that tells me that sine theta is equal to 1 minus cosine squared theta. Or I could do the same thing with and solve for cosine squared theta. If I have cosine squared theta solved for, I'll be subtracting sine squared theta to both sides. And so I could also say right here that cosine squared theta is equal to 1 minus sine squared theta. Now, that just adds more difficulties to some of these problems, unfortunately, but you have to understand, hey, I could actually solve for some of these, or I might substitute by solving for either sine, cosine, tangent, secant, cotangent, or cosecant, depending on the problem. All right, and I'll show you how to use that later on in the examples. Next up, we have our cofunction identities. And so you can see right here, when I have sine times like pi over 2 minus theta, that is equal to cosine theta, and so on. We also have negative angle identities right here at the last part, where, for example, sine negative theta is equal to negative sine times theta. Well, like I said, have all of these on hand when you're doing your homework. I want to have them next to me as we go through these problems to help you guys out and see where am I getting some of these substitutions, or where am I substituting things and where am I getting them from. So let's go ahead and take a look at some examples here. There probably isn't enough space in the student journal, so that's why right here I went ahead and created a new sheet for myself to show how we can solve these things out. All right, I've got my fundamental trig identities that I'm going to be referring back to in order to help me solve these questions. Now, number 1 in the student journal asked to find the values of the 5 other trig functions of theta, because what they gave us right here to start off with is sine theta. So remember, the inverse of sine, hopefully we realize at this point, is cosecant. So I went ahead and I just need to take the inverse of it, and that's going to be 5 over 1, or just 5. So we have one of them down already. Now, just to kind of show you our reciprocal identities right here, let me go ahead and highlight the one I'm using specifically for this one, is that cosecant theta is equal to 1 over sine theta. So let me show you how we put this all together if I were to use my reciprocal identities, which you may have to do at some point in time. We got cosecant theta right here is equal to 1 over sine theta, and we realize that sine theta is 1 over 5. So 1 divided by 1 over 5. And if I'm going to solve this out, I've got 1 times 5 over 1, or 1 times 5, and guess what? I still end up with 5 right here. So there is one of our trig functions. So now we have to figure out others. Okay, we've got 4 others that we have to solve for. But all I know right now is sine and cosecant. Well, let's take a look in our lists. Is there anything that has sine or cosecant in it that will allow me to solve for another identity? And there's more than one way for you guys to solve some of these problems out. Okay, so you can be creative. Maybe you thought of something else. And so even though I may be solving it one way, you might be able to solve it using a different Pythagorean identity or any other fundamental trig identity to help you along the way. But as I go through this list, what I see next right here is this Pythagorean identity of sine squared theta plus cosine squared theta is equal to 1. And so why use that? Because once again, I know what sine theta is. I may not know what sine squared theta is, but I could substitute what sine theta is into the equation. Okay, so next up, what I'm going to go ahead and do is take our Pythagorean identity. I've got sine squared theta plus cosine squared theta is equal to 1. And remember, one of the things I said that we could do is take these equations and plug in what we know and then be able to solve for one of the other trig identities. I know what sine theta is, and that's 1/5. So let me go ahead. What I'm going to do is substitute in here 1/5. But I'm going to go ahead and put that to the second power because it's sine squared theta. And then I have myself plus cosine squared theta is equal to 1. I'm trying to figure out what cosine is. So next up, let's go ahead and solve that out. And I'm going to go ahead and subtract. Let's go ahead and change this 1 over 5. You know, that is 1 over 25. So I want to go ahead right here and put 1 minus 1 over 25. And once again, where am I getting that? Because that turns this 1 over 5 squared is 1 over 25. So I subtracted that to both sides. Next up, let's go ahead. Let's simplify this out. And you're going to want to make sure, all right, I got to get a common denominator, so I got to multiply top and bottom by 25 right here. So now I end up with 25 minus 1 over 25. So we got cosine squared theta is equal to 24 over 25. Okay. Let's go ahead and get cosine. Let's get rid of that exponent. So we're going to go ahead and square root both sides. And now I have cosine theta is equal to square root of 24 over 20 or over 5, because I can take the square root of 25 and that equals 5. It looks like we could do a little more right here. I could simplify that 24. And that should simplify down to 2 rad 6. All right, so there is cosine theta. Simply put, I can go ahead now, find the inverse of that, which happens to be secant. So secant theta, let's take the inverse of it. We got 5 over 2 rad 6. Now, I can't leave my answer this way because I can't have a radical in the denominator. And I saw time and time again in previous chapters, like chapter 8, where you guys would not rationalize, or you would not get rid of that denominator. So make sure you guys do that carefully. Easiest way, hey, let me go ahead and multiply both top and bottom by rad 6. So I'll simplify this, and I've got 5 rad 6, and then square root of 6 times square root of 6 is square root of 36, which simplifies down to 6. So 6 times the 2 that's already out there in front is 12. So we now have 5 rad 6, or 5 times rad 6 over 12, and that's secant theta. So we still have to find one more thing, or two more. We got to find tangent and cotangent. So what can we do here? Well, if I know what sine is, and I know what cosine is, I could, there's two ways for us to go about this. I could actually use this right here. Tangent theta is equal to sine theta over cosine theta. That's one option. I could also use right here, looks like, what do I have? I've got, I know what secant theta is, so I could actually use this equation as well that I'm highlighting in magenta. So I could use either of the two. It doesn't matter as long as whatever you're most comfortable with, maybe whatever you happen to see first. So let's try the tangent theta is equal to sine theta over cosine theta. And let's see what happens. I already know what sine theta is from the very beginning of our problem. That's 1 over 5. Let's go ahead and divide that by cosine theta, which we just figured out up above, and that is 2 rad 6 over 5. So once again, when I am dividing fractions, you got to multiply by the reciprocal. So I got 1/5 times now 5 over 2 rad 6. So let's now simplify things out. Cancel out the 5s, and I'm left now with 1 over 2 rad 6. Can't have a radical in my denominator once again, so let's go ahead and we'll multiply top and bottom by rad 6. Because now in my denominator, I won't have rad 6 anymore. What will happen is I have 2 times 6, which is 12, and I have rad 6 above. Okay, so there's tangent, and then so if we go ahead right here to the next part, we deal with cotangent. I just go ahead and take the inverse of that, and that becomes 12 over rad 6. Unfortunately, we have to once again get rid of our denominator. So we'll go ahead right there, multiply top by rad 6, and now I have 12 rad 6 over 6, which then simplifies down to 2 square root of 6. A lot of work just for our 5 trig functions here. But you know, if you carefully go through them, you have the list of trig identities next to you. I'm pretty sure you can go through them and find each and every problem. But there's one more thing. We're not done yet. Remember in the problem up here, we've got these restrictions. They have this right here. And it's there for a reason. Okay? It says that theta is less than pi, but it's greater than pi over 2. Well, what does all that mean? Remember, if we take our quadrant right here, and remember, I told you, hey, you should know certain things in radians. 0. It's along our initial side. That's also the same thing as 2 pi, right? Up above, right here, at 90 degrees, remember, that is going to be pi over 2. At 180 degrees, we have pi. And then down at 270, we have 3 pi over 2. So you got to know your angles and radians. And what they're saying right here is that theta is in this section right here that I just highlighted. Well, remember, we have all students take calculus to help us remember what is positive in each quadrant. And so right here, in quadrant number 2, only sine and cosecant is positive. So now I have to go through my problems and determine one last thing. Okay, so let's figure out our other 5. Cosecant right here is good. Okay, so we'll go ahead and keep that as is, because sine and cosecant, they're inverse of each other, they're positive in the second quadrant. But let's go through the rest. Cosine right here needs to be negative. Okay, so this right here is our answer for cosine theta. For secant theta, this right here also needs to be negative. So I'm going to go ahead and add my negative sign for secant theta. Then we go to tangent and cotangent. All right, let me go ahead and highlight. We have tangent theta is equal to rad 6 over 12, but it needs to be negative rad 6 over 12. And then same for cotangent, we need to have our answer be negative 2 rad 6. And now we have finished solving for all 5 other trig functions in this problem. All right, and that's all based off of using these fundamental trig identities. There's different tricks that we're going to cover, and as you could kind of see how I put them together to solve our questions. All right, so that took up quite a bit of time. Let's go ahead and take a look at the next problem. Take a look at number 5. And they're saying, let's simplify the expression. Well, tangent theta divided by secant theta, like what does all that mean? Well, let's see what things that I could use from our fundamental trig identities here. One of the things that stand out to me is tangent theta, and knowing that, hey, that's equal to sine theta over cosine theta. Okay, so that's one thing that I'm going to be using right here. Okay, what else do we have here? What do we know about secant theta? Is there anything that we have where secant theta is by itself? And I see right here one of my reciprocal identities. So let's go ahead. I'm going to now substitute those trig identities right here into our equation. So tangent theta, I'm going to go ahead and rewrite that as sine theta over cosine theta. I'm going to divide that, and don't forget, we do have a negative, so I'll go ahead and stick that up above. And then in my denominator, I'm going to go ahead and rewrite secant theta as 1 over cosine theta. And when I'm going to go ahead and divide fractions right here, don't forget, we go ahead and we multiply by the reciprocal. So I've got sine theta over cosine theta times, right here, the reciprocal is cosine theta over 1. And guess what? This looks pretty nice. Cosine theta cancels out, and I'm just left with negative sine theta. Looks like I simplified things out right here. And there you go. There is your answer. Hey, make sure you show all your steps, show your trig identities that you're using to substitute and simplify things out. The next problem we're going to look at, number 6. Same thing, another problem that's asking us to simplify. So I've got my list of trig identities right here, and let's see what I could do. That cosine times pi over 2 minus theta, I see right here, that's one of my trig identities, that equals sine theta. Now, I don't see really anything that looks like 1 minus cosine squared theta, but there might be something that's close to that. But before we get to there, let's go ahead, let me change this cosine times pi over 2 minus theta. We'll change that to cos, or change that to sine theta. And let's see here. What's the closest thing that I could get that looks like 1 minus cosine squared theta? What if I take right here this Pythagorean identity that we've used quite a bit already, and so you can see it's pretty popular. If I take sine squared theta and I go ahead and I set this equal to 1 minus cosine squared theta, because I subtracted cosine squared to both sides, oh man, that looks like this. Now it looks like the same as that, right? They are both exactly the same. So now I can go ahead and substitute in right here for 1 minus cosine squared theta, sine squared theta. Now I can go ahead and multiply the two together. I now have sine cubed theta, and that right there is my simplified expression. All right. Let's try one more problem, and it's going to be about, it asks, number 9, to verify the identity. They're saying, how could I take 1 minus cosine squared theta divided by secant squared theta minus sine squared theta, and how does that equal negative sine to the 4th power theta? So we're going to have to do a little bit of manipulating here and see, along the way, how could I get all of this right here? Whoops. How can I get this to equal negative sine to the 4th theta? All right, so if I look right here, let's take a look at what are some things that I could substitute. Okay, that's what it comes down to. I see secant theta, and one thing that looks kind of similar to that right here is secant. Although one is secant squared theta, the other one is 1 over cosine squared and secant. Pretty close. So I'm going to somehow use that. That 1 minus cosine squared theta looks like I will probably have to use this right here again. And let's see what happens. If I have sine squared theta, and that's equal to 1 minus cosine squared theta, they're not exactly the same, or are they the same? Looks like right here. Let's see. They're not the same. 1 minus cosine. Oh, hey, look, they are exactly the same. So let's see what we could do right here with that. Looks like for our numerator, right, I can go ahead and take this and substitute that in there. So now my numerator, let me go ahead and I'll put 1 minus cosine squared theta and change that to sine squared theta. The secant squared, let me go ahead and put right there. I will substitute and change that into 1 over cosine theta. However, in order for it to be the same, I'm going to go ahead and need to take this 1 over cosine squared, or 1 over cosine theta, and square it. And then we have right here minus sine squared theta. And then we're going to need to simplify this down a little bit more. Okay? Well, if we go ahead in purple, we'll have sine squared theta. And then if I go ahead and in purple, this will change into 1 squared over cosine theta, or cosine squared theta. Okay. So if I go ahead and multiply by the reciprocal because we're dividing, this will now turn into cosine squared theta over 1, which we don't need to write. Okay, that's not necessary. So we have this together, And then we have the minus sine squared theta. If I look at the expression now, something you learned in algebra here is that, hey, they both share something in common, and we're going to go ahead and factor that out. So what am I going to factor out? Sine squared theta, and what I'm now left with is cosine squared theta minus 1. Because if I were to take the sine squared theta right there and distribute it out, it will look like what we have up above right here. So we are at that. We have that down, and let's go to this next stage. What do I have right here that looks just like that? Look right over here. What do we have? We got 1 minus cosine squared theta. It looks very similar to sine squared theta, but it's not. But what if I did this? What if I went ahead and I took this right here and I rewrote it as -1 plus cosine squared theta? And let's say I factored out the negative. So it becomes 1 minus cosine squared theta. Looks like that part that I just highlighted in purple. So what I'm going to do now is go ahead and substitute right here. And this substitutes into sine squared theta, right? It changes. But now we have this negative that's in front. So we're almost down right here to the end. And I'm going to go ahead and put sine squared theta. And then that, and we multiply it and substitute it with negative sine squared theta. For our last step and final step, we're going to go ahead and multiply the two together, and sine squared times sine squared, that'll get us sine to the 4th power theta, and we have a negative out in front, and look, they look the same now. Ta-da! All right, you got to practice them. There's no way around it. It's a long section. You can see how a lot of the last 2 sections in chapter 9 have been a little challenging. All right, but it takes practice. I know you can do it. Make sure you come to tutorial if you need any extra help or ask some questions in class. All right. If I helped you out in any way, hey, leave a comment, let me know. Make sure, please subscribe, hey, and like the video as well. Have yourselves a great day.